So here's our warm-up. Miss Diaz has 150 students. 2 out of 3 buy lunch. How many total students buy lunch? So we're looking at how many total students buy lunch. First thing about a fraction is part over whole. We've seen that before, I believe. We've talked about it. A fraction is part over whole. What that means is if I have a pizza right here and I cut out one terrible slice, we'll make my slices better. And I have this, what fraction of the pizza is that? What fraction of the pizza is that if it looked a little bit better? Yeah, it would be 1/6. It's not that great. In fact, it would be better if it was like this, and that's a little bit more even, but I didn't want to change it in the middle. So it's like 1/8. So that's part. This is the part of the pizza I ate out of the whole pizza that was there. We can do that same thing in our stuff. We have this, our part over whole. We know our part was 2, and our bottom was 3. That was in our warm-up. 2 out of 3. 2 out of 3. And we know that how many students do I have in total? How many is my whole, Rafi? 150. So that goes on the bottom because that's the whole. So now I need to find the part. We're going to block it off with a nice X so that we know what we're looking for. All we're doing is finding an equivalent fraction, just like we did before. How can I go from 3 to 150? How can I go from 3, Roman? That's not what I called on you for. Elsie. Yeah, times 50. Times 50. So what am I going to do to the top number? Madison? Times 50. Same math that we've been doing. Whatever we do to one side, we do to the other. If we don't do it this way, our fractions are not equivalent. So 3 times 50 is 150. What's 2 times 50? What's 2 times 50, Malia? 100. So in our math, 100 of Miss Diaz's students buy lunch. Yes, Lucy. So Lucy also pointed out something else. She pointed out that she took the 150 students and split them into 3 groups. She divided 150 into 3 groups because it was 3 students. So she got 50 in each group. This is 50 times 3, or repeated addition, we get 150. And then she multiplied the group times 2. Just combined these. We get 100. There's many ways we can solve fraction problems because fractions lend themselves to be multiplied or divided easily since multiplication and division are the same thing. So let's read this question. The ratio of texts that Daniel sends to Ben is 3 to 4. Daniel sent 18 texts. How many did Ben send? So I want you to work on this. I want you to try this problem. If you're confused, like I said, we just set up a number sentence for our words. How many texts did Daniel send? How many texts did? 18. Yeah, he sent a total of 18 texts. Do we know how much Ben sent? No. So we're going to put an X because it's our unknown. All that means is it's a placeholder. Now, what's the original ratio? Daniel sends text to Ben is 3 to 4. So what's the ratio on the other side? It is 3/4. Exactly. How do we get from 3 to 18? Times 6. How do we do the same thing here? What's 4 times 6? 24. So X is equal to 24. We can do this another way. We could divide and multiply. We can do all sorts of different things. The important part is that we know which piece goes where. If you're wondering and you said, but I put Ben on the top, that's fine because what we can do is the ratio is going to be the exact same. We would have Ben on top, Daniel on bottom. Ben sent 4, Daniel sent 3, Daniel sent a total of 18, and Ben sent an unknown amount. It's going to be the exact same ratio. It's going to be the exact... It doesn't matter which part of the fraction is where, as long as they are both the same. So we have Ben and Ben over here, and we've got Daniel and Daniel down there. Both ways work. Daniel, Ben, it doesn't matter. Both ways work. I want you to practice this one. The Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they travel on 6 gallons of gas? So we're going to set up our fraction the same way. They say find the unit rate, but there's, which I suggest, by the way, actually, but there's several things. What's our initial ratio? Who can tell me the initial ratio? It's going to be forming a number sentence. So just read the question and pull out the numbers. What's our initial ratio? Elsie?
104.
Perfect. We can put either one on top, either one on the bottom, as long as we match it in the end. And what are we trying to find? We're trying to get to 6 gallons. Can we multiply from 4 to 6? No, we can't do that. So what we're going to do is we're going to go back, find our unit rate, and then hop forwards. We're going to do scaling. So I want you to try that. One thing we could do, we could find the unit rate, or we could even do it for the rate of 2, because 2 also multiplies. But it doesn't necessarily matter. 4, we divide it by what to get to 1? What do we divide it by? Show me your fingers. By 4, you guys, super easy. So we're going to do the same to the top. What is 105 divided by 4? What is 105 divided by 4? We might have a decimal. Let's see what it is. Rocco. 26.25. Correct. And we got this. We can do our long division over here. We know that. 4 goes in 0, 2, 8, 2, 5, 6, 24. We get 1 left over. We bring down a decimal 0. It goes in another 2 times, and then it finally goes in exactly 5 times. It also makes sense because 104 is exactly divisible by 4, right? 104 is exactly divisible by 4. That's 26. 100 divided by 4 is 25. Think 4 quarters. And 100, and then 4 divided by 4 is 1. So that's how we get 26. And then we have 1 whole left over being split into 4 parts. So it's going to be 1/4. Exactly. So we did the dividing by 4. Now we need to do the multiplying by 6. So let's do that multiplying by 6. Hold on, I'm going to go and do it over here. So we got 26.25. And we multiply that times 6. Where do I line up the 6? We already did some multiplication. Jaden. The what? So I line it up like this? How do I line it up? Ben? Under the 5. Whenever we're doing multiplication, we always push everything to the far right side. And then we do our math. 6 times 5. 30. 6 times 2, 12. Plus the 3 is 15. 6 times 6, 36. We get a 7. 6 times... We get... Yeah. Wait. 6 times 2, we get a 12, and that's another 15, right? We had 2 decimals here, so we have 2 decimals here. So our answer is 157.5. Let's see this. Ready? It's at the bottom because we had the answer there. It's 157.5. What we did is we did scaling, if you saw. This is scaling just like we've done in earlier lessons. So they want us to like draw a double number line, but we don't really need to draw a double number line because we're smart students, right? Also because drawing a number line is a total hassle. Also because drawing a double number line is a total hassle. But if we did that, at 1, we found out that it was 26.25. If that helps you, then we multiplied to get to 6. We got 157.5. So there's many ways that we can do this. I want you guys to open to page 73 and pick 2 of A, B, or C. A, B, or C. So we're doing problem A. In a survey, 4 out of 5 people preferred creamy over chunky peanut butter. There are 120 people shopping in a grocery store. Use the survey to predict how many people in the store would prefer creamy peanut butter. So Nathan, how'd you go about doing it?
Oh, so I got 4 out of 5.
So he wrote the initial ratio, which is 4 out of 5 people preferred creamy to chunky. And then he set that equal to an equivalent ratio to what?
120.
And what goes on the bottom?
So I multiplied it by 30.
Yeah, so he multiplied it by
30.
times 30. So we did the same to the bottom. And what did you get for your answer?
150.
150. So, how many people in the store actually, let's see, we did it a little bit backwards.
130.
We did it a little bit backwards, but we're gonna try it one more time because that was my fault for not catching it too. So, if 4 out of 5 people, remember, what is the total amount of people? What is the total amount of people?
120.
There's 5 in our first fraction, 5 people total and 120 total. We always have to keep the same on the bottom. The bottom right now is our total, and this is our part. So it's the same thing. How do we go from 5 to 120?
Divide.
5 goes into 120 24 times. So we're going to do that the same way. So Nathan, what is 4 times 24? You can do your work there.
So 24 times 4.
Stop.
I got 16.
No, I can't.
Then 8, 9. And
So we get our X is equal to 96. 96 people in that store are going to prefer creamy peanut butter, and I'm one of them. Thank you. Now we're going to do B. So here, a survey found that 12 out of every 15 people in the United States prefer eating at a restaurant over cooking at home. If 400 people selected eating at a restaurant on the survey, how many took the survey? So we're setting up our initial fraction. 12 out of 15 prefer eating at a restaurant. Which is the restaurant, the 12 or the 15? Which is the restaurant, the 12 or the 15? Who can tell me? Rocco. The 12. That's the restaurant. So if 400 people selected eating at a restaurant, is the 400 going to go here or is it going to go here? Which place? On the top, because we keep restaurants and restaurants on the same sort of fraction. So now, how do we go from 12 to 400? The easiest way is to just divide. How do we go from 12 to 400? So here, how many times does 12 go into 40? It goes in 3 times. That's 36. 4. 40 again. That means we're going to get another 3. And we're going to get another 3 and another. So we just write it like that. Times 33.3. We're going to do the same to the bottom. Times 33.3. 15. And then it's 33.3. We get 15. 15. 15. 3, 3, 3. We add all of this together. And we get 5, 9, 9. I feel like I did something wrong. No, not yet.
Yeah.
I forgot the one because it's 16. That's where we were having our problem because I knew that wasn't the right answer. So we get 499.5. 1 decimal that way, 1 decimal back. Can we have 0.5 of a person? No. So we're going to round that. What is our X going to be? What is our X going to be in this case? If we have 499.5, who can give me a good X? Anita. 500. Exactly. 500. Great job, you guys. So this question states, there are 810 calories in 3 scoops of vanilla ice cream. How many are there in 7 scoops? So what's our initial ratio? What's the initial ratio?
7.
So our initial ratio, we have 810 calories split with 3 scoops of vanilla. We can write the fraction however we want. We can have the 3 on the top or the 3 on the bottom. But this 3 is scoops. That's scoops. It's a bad spelling of scoops, but it's scoops. So what goes on? Where does the next part go? 7 scoops. Where does that go? Top or bottom? Excellent. It goes on the top. Can we get from 3 to 7 easily? Can we get from 3 to 7? No. So we're going to unit rate it. We're going to unit rate it. We have 3 over 810. We're going to unit rate it. Get it down to 1 over something. What's 810 divided by 3? What's 810 divided by 3? We can do our long division. Okay, how many times does it go into 21?
7.
7 times. It's an even 21. We get 0, 0, 0. So our unit fraction is 1 over 270. Now we can go from our unit fraction to our now 7. We get 1 over 270. How do we go from 1 to 7?
Multiply.
By 7. So we're going to do the same to 270 times 7. $270 times 7. So we don't need to put the 1 there because we're going to put it at the bottom. What's 7 times 2?
14.
14 plus the 4, we get 18. So how many are in 7 scoops? Our x is equal to what?
1,890.
Excellent! It's equal to 1,890. Great job, Oswaldo. Sit down.